All right, so problem 8, the chapter 5 practice test. So this one is very conceptual. So I'm gonna, kind of give a thorough explanation and, really talk a lot, I guess, because I want to make sure you understand it. It's one of those where like there's not really like a work I can show you per se, in the sense where like you have to just get what I'm saying or get the concept. So forgive me ahead of time if I feel like if it seems like I'm talking a lot. But anyways, here we go. So for events A and B related to the same chance process, which of the following statements is true? If A and B are mutually exclusive, then they must be independent. Okay, so if two events are mutually exclusive, that means that they can't occur together. So mutually exclusive events mean, let's say A and B. It means the probability of the probability of A and B is equal to 0. Mathematically, that's what's going on. Like you can't have both events occur. So the probability of A and B would have to be 0 to mutually exclusive. Now, just because the probability of A and B is equal to 0, that doesn't mean they're independent, because to be independent, that means mathematically speaking that the probability of A given B is equal to the probability of A, and the probability of B given A is equal to the probability of B, meaning that the probability of each event is not affected by the other event occurring, but they can still both occur. It doesn't mean that they both can't not occur. It just means the probabilities of each is not going to be affected by the other one occurring. So it's not going to be A. Problem B or answer B, if A and B are independent, then they must be mutually exclusive. The other way around, um, if they're independent, then they must know. So again, it's kind of just the same thing. It's kind of just going backwards. Instead of going from mutually exclusive to independent, we're going from independent to mutually exclusive. This doesn't infer that, and this doesn't imply that. This is so like, yeah, same sort of thing. If A and B are not mutually exclusive, then they must be independent. Okay, so if they're not mutually exclusive, that means the probability of A and B is basically not equal to 0. Probability of A and B is not equal to 0. Um, this doesn't tell you really anything about if they're independent or if they're not independent. It just means that they both can occur together. Um, that gives you no information um, about what their probabilities are or whether or not one event will affect the other. So C is not going to be an answer either. D, if A and B are not independent, then they must be mutually exclusive. So if they're not independent, that means that the probability of A given B is not going to be equal to the probability of A, and the probability of B given A is not going to be equal to the probability of B, meaning that the probabilities are affected by the other event occurring. And it's again just going backwards from this. It's kind of just going the other way around. Just because one event affects the other one, that doesn't tell you that like they both can't occur together. Um, actually, hold on. Duh. Actually, no. This is actually I worded that wrong. If they're non-independent, then that means then that means that one event affects the other. One the but then it doesn't mean that they're mutually exclusive, because if they were mutually exclusive, then they both couldn't occur together. They both couldn't occur. So like the fact that one event can affect the other basically tells you that they both can occur. Like like in order for something to affect something else, they both have to be able to occur. Like I guess maybe like you could think of it like like the number of hours the number of hours you sleep affect your test score. So like those would be that would be an example of, you would say, of events that are not mutually exclusive and they're not independent. So it's not D either. And then E, it's going to be E just as a process of elimination, but let's go over it. If A and B are independent, then they cannot be mutually exclusive. If they are independent, then they cannot be mutually exclusive. So the way you want to think about this one would be, so let's put it, if we're talking about this. Now, in order for us to know that the probability of A given B is equal to the probability of A, that means that it has to be possible for both of them to occur, because we wouldn't be able to know that the probability of A wasn't affected by B unless they both could occur together. For example, like you wouldn't know if the amount of sleep you got would affect your test score unless they both could occur, which they do obviously. But you sleep and then the next day you take a test. You wouldn't be able to even say, you wouldn't be able to have any any conclusion about whether or not A affects B if they both could not occur together. So then they cannot be mutually exclusive, because if they were mutually exclusive, that means they couldn't occur together, which doesn't make sense for us to say that they're independent. And so then this would have to be the true answer. I hope I explained that well, because I know this stuff can be a little confusing, but just let me know. Let me know if I can clear that up, because I know with the wording of the probability conditions, it can kind of drive you crazy. But yeah, I hope that helps. And I'll see you guys in the next video.